All right, we're going to start the chapter on circles with a few definitions. Here is the official definition of a circle, the set of all points equidistant from a given point. Here's what that means. Here is the given point. Here's the distance. We're going to use that distance and go all the way around that point. Now, if we do this forever, we're going to get a set of points that form a circle. The center is usually the name of the circle, right there. The radius is the distance from the center to the point on the circle. All radii on the circle are congruent. They're all the same. You guys all know what radius means. There it is. And then of course the diameter is the distance across the center across the circle through the center. It's the longest line you can draw inside of a circle. So all of these definitions you already should know. Let's go on to newer definitions. Here are some newer definitions. A chord is a segment whose endpoints are on the circle. There's a circle, there's a chord. Its endpoints are on the circle. A secant is a line that intersects the circle in 2 points. Here's a circle. There's the secant line. It goes through the circle and hits it in 2 different places. A tangent is a line that intersects the circle in exactly 1 point. Here's a circle, and then here's the tangent line. It only touches the circle at 1 point. Tangent circles, coplanar circles that intersect at exactly 1 point. So we have circles that intersect. There's an external and an internal. The first one is an external tangent circles. They're on the outside of each other, and then the next one are internal tangent circles. One's inside the other. Concentric circles. Concentric circles are circles that share the same center, like this. Otherwise known as a bullseye. Let's do an example. Go ahead and study that picture for a little bit. Now we're going to identify each line or segment. Go ahead and find a chord in that picture. Yes, the chord is segment DE. You can also use ED. It doesn't matter the order you put it in this case. Go ahead and find the secant. Remember, the secant is a line that goes through the circle and it touches the circle in 2 different places. The obvious answer is line AF. Notice on top of the AF there's 2 little arrows. That just means that we're talking about the line and not the segment. There's another way you can write the answer. If I put line DE, that is also an answer. It's different from the chord, which is only a segment. You can also put line A if you wanted to, or line F. All of those answers will be acceptable. Let's find the tangent. Remember, the tangent is the line that touches the circle only at one place. GH. Another way of writing that answer, line G or line H. The diameter, that one's pretty easy. Segment DE. The radius, we actually have a few radii. The obvious is segment CB. You can also choose segment CE or CD. All three of those are acceptable. Point of tangency. Remember, the point of tangency is the point where the line touches the circle. In this case, we have point J. Let's analyze some circles on graph paper. Here we have two circles, a big one and a small one. Find the length of the radius of both of the circles. Notice the length of the smaller one is 2 units. The radius of the bigger one is 4 units. The point of tangency is where they touch each other. The point of tangency is at -2, 3. Right here. Okay. Let's do the line of tangency. That's the line that touches both circles at one place. Here it is. There's a line that touches both circles. Now, how do we write that as an answer? To write the equation of a line that goes up and down, it is always x equals, and wherever that line is, in this case it's -2. Let's quickly review the formula for the circumference of a circle. First of all, the definition is the distance around the circle. Here's the formula. Circumference equals 2 pi r. Some of you guys know it as circumference is equal to pi times the diameter. Both equations will work. They're exactly the same. Let's go ahead and do a real live example. In 2015, Roger Federer and Andre Agassi played tennis on a helipad on top of a hotel in the United Arab Emirates. The helipad has a diameter of 79 feet and it was 700 feet high. Find the circumference of the helipad. So that's not too bad. You can start with the formula. And then I know it gives you the diameter, but to find the radius, you just split it in half, which is 39.5. Multiply all of them together on your calculator, remembering to use the pi button and not just 3.14. It turns out that the circumference of the helipad is about 248.1856 feet. Let's go backwards. Here is a picture of the Capitol Records building in Los Angeles. It has a circumference of 850 feet. You have to go backwards to find the diameter. Here's the formula for the circumference, 2 pi r. Let's plug in what we know. It turns out that the circumference is 850, and then we have 2 pi r. To solve for r, just divide both sides by 2 pi, and the radius is 135.2818. And then finally, to find the diameter, just double that answer. It should be approximately 270.5636 feet. All right, let's talk about inscribed versus circumscribed shapes. Right now we have a picture of a circle and a triangle. It is said that the circle is circumscribed about the triangle, so the circle is outside of the triangle. Or you can say that the triangle is inscribed the circle, so the triangle is on the inside of the circle. All right, let's go ahead and do a Common Core problem. It says that a 9 by 12 rectangle is inscribed in a circle. Find the circumference of that circle. All right, the first thing we need to do is draw a picture. A rectangle inscribed in a circle. Here it is. It is 9 by 12. To find the circumference, you need to find the radius of the circle. There is a radius. Notice it goes to the corner. I drew it conveniently so that it makes a right triangle. The height is 6 and the base is 4.5. Use your Pythagorean theorem, a squared plus b squared is equal to c squared, and you will get the radius to be 7.5. Plug it back into your circumference formula. Punch it all into your calculator. You should get 47.1239 units. Let's do the last problem for the day. A square of perimeter 76 centimeters is circumscribed about a circle. Find the circumference of the circle. Our first job is to draw a picture of a square that is circumscribed about a circle. There it is. Now we have to find the side of each side. If the perimeter is 76, divide that by 4 to get 19. And then to find the radius of the circle, we cut that in half to get 9.5. Using the formula for circumference of a circle, plug in the radius and then everything else into your calculator to get 59.6902 centimeters. All right, that's all for today. Thank you.